Imagine a teacher who only looks at the total score, not the subject. A score of 0 in math and 100 in Chinese is the same as a score of 50 in math and 50 in Chinese. Then as a student, would they truly know which subject they excel in? Today we'll analyze the information from Nvidia, GDPO, Group Reward-Decoupled Normalization Policy Optimization for Multi-Reward RL Optimization. This paper proposes a new version of GDPO, re-answering the question, how should rewards be compared? In other words, in current training, meeting one objective and meeting multiple objectives are being treated as the same thing. This phenomenon of compressed reward semantics is particularly detrimental in multi-reward RL scenarios. A common approach is to sum all rewards directly, and then apply GRPO as if it were a single reward. However, this leads to a problem. GRPO, group-wise normalization, maps different reward combinations to the same advantage pattern. To illustrate how this semantic compression occurs, the paper provides an example. Although removing STD seems like a clever fix, as it can distinguish between 1 and 2 in this case, the information compression problem still exists when there are many rewards and rollouts, and training becomes very unstable. The paper empirically demonstrates 0% format. The GDPO's approach to correction is very clear. Do not change the meaning of reward, only change the stage at which normalization occurs. Step A. Perform group-wise normalization for each reward individually, then add up the advantages of each dimension to get the total advantage. Step B. Perform batch-wise advantage normalization again. The purpose of this step is to control the numerical scale. Under these settings, the authors tested GDPO's performance on different multi-objective tasks. The effectiveness of GDPO does not stem from a new reward design, but rather from the decoupling and alignment of multi-objective signals. This also reveals an important fact. The priority of multiple rewards cannot be achieved simply by adjusting weights. A better conditioned reward is one where the length reward only applies when the answer is correct. In summary, the problem with multi-reward RL may not lie entirely in the design of the rewards, but rather in how the rewards are compared and compressed. However, in practical applications, finer reward distinctions are helpful, but further granularity can introduce new problems. Can the multi-reward mechanism of PPO also be optimized? We'll leave these issues for future discussion.